So in question 1 here, it's asking us to use the new equation and the old equation to find my weight. And they're saying that I have a mass of about 55 kilograms. And are the numbers different? So the way we would do this is by simply the old way. So this is kind of the old way. We just sort of assume this flat earth, nothing going on. We say Fg, and we know that Fg is equal to mg. If my mass is 55, and G is 9.8, we're just using 9.8 as a reference, we get an answer of 539 newtons. Okay, and that would be my weight. So this is, when we say Fg, this is my weight, my actual weight on the Earth. Is that. Okay, now to do this the new way, we have to use our new equation, which is the one for the universal gravitation. So we would start by going Fg equals big G, m1, m2 over the distance between the two objects squared. So now what we said in class was that the two masses, we can actually write them in here. Let's just say the two objects involved here are mass of Maya, that's me, and the mass of the Earth. Okay, and what's the distance? You might think the distance is 0 because I'm standing right on the Earth, but what we actually say is that the distance is, if you average out all the different parts of the Earth that are exerting a force of gravity on me, they would all average out so that the distance that you would use would actually, in this case, be the radius of the Earth. And that's always given to us. So let's just make a note of that because that's important. When you're talking about things on the surface of the Earth, you're talking about the radius, the distance is the radius of the Earth. Okay, so the distance is not 0, otherwise the force would be infinite. That wouldn't make any sense. Okay, so let's plug in the numbers, and when we do that, we just have to be careful with our calculator. So this equals G, the mass, okay, so let's actually plug in the numbers. So that's 6.67 times 10 to the negative 11. The mass of me is 55. The mass of the Earth that you're given is 6.38 times 10 to the 6th meters. Divide that by the radius of the Earth, which is I've got this wrong. This is actually 5.98 times 10 to the, let's see, 5.98 times 10 to the 24. Times 10 to the 24. And then the radius of the Earth is 6.38 times 10 to the 6. Okay, so a lot of people get to this point and they still, and then we square that. That's one of the reasons people can sometimes make mistakes. I'm going to put my calculator here just because I feel like it is worth going through the calculations. This is the old school calculator. I will also do this with my graphing calculator so you can see how I do it. But 6.67, I'm going to use the exponent button, exp, negative 11 times 55 times, and then 5.98. This is 24. And then when you divide it, make sure to use if you can either use the exponent button or parentheses, but you can go 6.38 exponent 6 squared. That should work. And that gives me a number of 538.9. 538.9 newtons, which you can see rounds to 539 newtons. So these two, again, are the same. So the weight is the same in both examples. They should be the same because this is supposed to be universal. It's supposed to work everywhere. This 9.8 only works on the surface of the Earth. So that's how we use it.